Hey friends, welcome to 1 Minute Math. Today we're going to be talking about a calculus concept. This is kind of like a medium, moderate length video. We're just connecting the graphs of f prime, and f double prime, or maybe even connecting the behavior of those functions. This is probably the beginnings of applications of differentiation. This would be midway through your College Calc I class or midway through your high school AP Calculus class. The important thing is here we want to understand how these three different functions affect each other, what they mean, what conclusions we can take. So hopefully you're familiar with the fact that f prime describes the uphill and downhill behavior of our function f. It basically talks about the slope, right? F prime gives a slope of f. So in particular, if f prime is positive, we know that f is going uphill. But now f can go uphill two different ways, right? In this first column here, I'm talking about f prime positive. Actually, f prime could go uphill lots of different ways. But the two that I'm thinking of, if I'm not just going straight uphill in a line, I might be going uphill in kind of a smiley sort of a way, or I might be going uphill in kind of a frowny sort of a way. In this case, the slope itself is increasing. In this bottom one I've drawn, the slope, while still positive, is getting smaller as x goes forward. So that gives rise to these two pictures. Whoop. If f prime and f double prime are both positive, we get a portion of our graph of f that is, it's kind of looking like the right side of a smile. It's that uphill part, but in a smiley sort of a way. The slope is increasing. The slope is positive and getting more positive. If f prime is positive, but f double prime is negative, so f double prime measures the rate at which the rate is changing. Rate at which the rate of f is changing. And I want to really encourage you, if you're talking about these functions, that you use their proper names, okay? And we distinguish between positive and increasing. Those words do not mean the same thing, okay? This curve up here that I've drawn has a positive slope everywhere, and that slope is increasing. What I'm going to draw down here is that one that I had on the bottom of these when I was looking at it. The curve here has positive slopes everywhere, but those slopes are decreasing. That means f double prime is negative. The rate at which the rate of f is changing is itself negative. The rate of f is going down. So likewise, we're going to get some pictures over here. If f prime is negative, then I get these three possibilities. And this one's a little bit trickier to get, because if f prime is negative and f double prime is positive, you might think that the slope is getting more accentuated, but really what's happening is that the slope here is approaching zero. The slope is getting less negative. The slope of f is getting less negative. And down here we've got the slope of f is negative everywhere, and it is becoming more negative. When we say increasing and decreasing, right, those are about the actual values of numbers, not their magnitudes. So going from negative 10 to negative 2, that's an increasing action. Okay, even though the size of negative 10 and the size of negative 2, the sizes of them are shrinking, and that's the difference between velocity and speed, and that's in another video. So anyway, take a mental snapshot, put this little chart in your notes. This is going to be super handy for you. Some vocabulary that you need to know. You should be aware that a critical point is any x value where f prime equals 0 or f prime does not exist. And those critical points, those critical values give us the possible places where turning points of the graph of f might exist. Maxes and mins, could also happen at endpoints of an interval, but turning points like relative maxes, local mins, those things happen where f prime changes sign. So critical points, we get those values from f prime, and we know that maxes are when f prime, if I have a maximum, the slope of f was positive and then was negative. So a maximum occurs when f prime changes from positive to negative. I can even put the word sign in here, changes sign. Oh, my word. If there's one phrase that you're going to remember, if you have room in your brain to tuck away one memorized phrase that you're going to use on the AP exam or your next college midterm or something, it should be the phrase changes sign, not equals 0. A maximum does not occur where f prime equals 0. It occurs where f prime changes sign from positive to negative. Likewise, a minimum is going to occur when f prime changes sign from negative to positive. Okay. F was decreasing, then F is increasing. Notice how I did not say F prime changed from increasing to decreasing. Okay, so if you want another thing for your notes, F increasing means the same thing as F prime positive, and then F decreasing is the same as F prime negative. Okay, so don't try and put those together. We're not going to say f prime increasing, f prime decreasing, unless that's actually what you mean. So our last vocabulary here is inflection point. An inflection point. So let's say I'm looking at a graph of f. This is my f here, and f is going to, let's make f increasing the whole time, but it's going to increase in different ways. Remember that chart we had where like some of them were smiley and some of them were frowny? So not a max or a min, but a point where the rate of the rate changes. Those are what we call inflection points, and they are x values where f double prime changes sign. Okay, and that's another one. You just want to kind of commit that to memory. Okay, so concavity, we would call this part concave up. Concave up, and this frowny part, we're going to call that concave down. Let's go over to our little chart where we were connecting those things. F increasing means f prime positive, f decreasing means f prime negative. F concave up means f prime increasing, which means f double prime is positive. And we're going to say the same thing for f concave down. This is our last little slide here. This is our last bit. And again, I would definitely put this in your notes or take a mental snapshot. Just make sure that when you're trying to state something or justify something that you're saying, that you're using the appropriate vocabulary to go with the function you're talking about. Also notice nowhere on the slide have I said it. It is increasing when f prime is positive. Just take the word it and remove it from your vocabulary if you're being asked to justify or support why an interval might represent f increasing, or why this x value might be a max or a min, the location of a max or a min, okay? F increasing means f prime positive, f concave up means f prime increasing, means f double prime positive. Those are all interchangeable, but they're not mix or match inside, like between lines. Okay, I hope that was helpful for you. Thanks for listening. Catch you next time.